ChatGerry, Math Physics Medicine, MPM, and Viscoplastopology, VPT, Differences, Similarity, and Evolution. Part 1. Number 1457, VPT Sharp 020, December 5, 2025 0530, Gerald C. EclaireMD Foundation. Category, Medical Research Methodology. At 0530 a.m. on December 5, 2025, I woke up with a clear realization. My two major research frameworks, Math Physics Medicine, MPM, and Viscoplastopology, VPT, are not separate academic branches. They are two expressions of one deeper structure. This article documents how these methods grew, how they differ, how they align, and how they evolved into my unified Viscoplastopology, VPT, approach. I have always believed that almost everything in life can be quantified. Music is built on simple intervals like do re mi, or 1 2 3. Human emotion, memory, metabolic waves, and disease progression all carry measurable patterns. If we look deep enough, with engineering training and 16 years of medical self-study, I naturally see the world as numerical structure, system, dynamics, frequency behavior, and cause-effect pathways. This explains why analog systems were replaced by digital systems. Once signals are quantifiable, noise can be removed, patterns can be reconstructed, and truth becomes clearer. Artificial intelligence, AI, follows the same principle. It accelerates tasks based on pattern repetition, risk, sorting, and large-scale comparison. Medicine will increasingly rely on this kind of automation. What remains uniquely human is intuition, creativity, empathy, passion, and moral judgment. Everything else will shift toward quantitative automation. My transition from math physical medicine, MPM, to viscoplastic medicine theory, VMT, began in 2020 when my MIT advisor, Professor Norman Jones, encouraged me to use viscoplastic methods. He understood that biology is time-dependent and non-resetting, and that my earlier medical research work relied too heavily on static, or linear math physics approaches. When I revisited my handwritten notes from 18 years of 6 university studies, I realized he never formally taught the viscosity component during my MIT years. His research on viscoplasticity was advanced, but still mainly in the research domain in the 1970s. Starting in 2021, after teaching myself viscoplasticity from scratch, I began modeling medical systems using the viscoplastic energy model of VMT. At first, I calculated everything by hand in Excel, then built a medical AI software on my iPhone to run the computations in seconds. I still draw my diagrams manually, because each graph preparation deepens my understanding. Through more than 700 VMT papers, I learned to see energy, geometry, curvature, and volume behind every dataset. Hard work is the cost of real insight. After my hemorrhagic stroke on June 21, 2025, something unexpected happened. My memory was somewhat damaged, but during recovery, something opened. Old knowledge from decades ago resurfaced. I remembered topology learned 58 years earlier, and stochastic methods learned 48 years earlier. Neuroplasticity reconnected forgotten neurons as if old drawers in my brain were suddenly unlocked. From October to December 2025, I wrote around 50 topology-based medical research papers. Unlike traditional topological data analysis, TDA, work that focuses on medical imaging, I applied topology to pathophysiology itself by mapping shape deformation, area change, geometric curvature, and data point connectivity. This gave me another way to see disease as a shape rather than a number. I produced only one paper using stochastic methods and then stopped due to my personal, strong belief that statistical averages are not suitable for life and death medical analysis. The key difference between my two methods is simple. VMT is based on physical energy. It measures the interaction between a single output, strain and multiple input stressors by calculating the enclosed area of stress-strain curves. TDA is based on geometry. It measures shape size, deformation, and connectivity through areas and volumes in n-dimensional space. On the surface, energy physics and geometric topology appear unrelated. But underneath, both methods analyze longitudinal, quantitative data, input-output relationships, and, most importantly, pattern recognition. They both search for the truth hidden inside evolving shapes of data across time. If we temporarily ignore the academic boundaries between engineering, physics, and mathematics, then both VMT and TDA belong to one domain, data science. More specifically, both belong to pattern recognition, which is one of the pillars of artificial intelligence. But unlike AI, human pattern recognition includes intuition, emotion, and creativity. AI repeats learned patterns. Humans create or recognize new ones. Up to this point, the article reaches my personal limit of around 2,000 words in the full version. I will continue the deeper, step-by-step technical comparison of MPM, VMT, TDA, and VPT in Part 2. Disclaimer: I write this paper not for fame, but to share what I have learned so others can understand their health, prevent disease, and live longer, healthier lives. This content is for educational reference only, and does not constitute medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered, edited, or republished as your own. All rights belong to Gerald C.